Alright dudes, what's up? Alright, let's do this. We are jumping in. I don't know something's up with like my mouse cord. Something is like pulling on it. It's a pain in the ass, but it's all good. Oh yeah, I want to go ahead and do this real quick. I wanted to get cursor, highlight, highlighter, Windows 11. Is this Windows 11? I don't even know what Windows 10. Yeah, that's right. I haven't upgraded to Windows 11 yet. To activate a cursor highlighter on Windows 10, simply press the Control key. Wait, what? What? No, it doesn't. What? Control. I don't need to watch an 18-minute video for that. Ah. Okay, so it's an add-on. That's what it's talking about, and it got it wrong. You gotta hit it twice. So they have visual indicators when the left, right. By default, mouse item can be turned off with the Win Shift H. Windows Shift H. Win Shift H. Windows Shift H. It's not working. Is this for Windows 10? Okay. That did not work, my dude. Let's see. Oh wait. Additional mouse options. Pointers. Display pointer trail. No. Show location of pointer when I press the Control key. That is not, no, that's not what I want. Yeah, no, that is literally terrible, honestly. That is so bad. Like, why would you? Why? That is not what we want, guys. Okay, so let's try this again. Mouse highlighter, Windows 10. Power Toys mouse utilities. A spotlight, or by shaking the mouse. Okay, so like this is some sort of, yeah, like this is that's good. That's what I want. No, I want the one. It's just like the yellow mouse highlighter. Click scheme. Mouse cursor highlight. I keep seeing this, but like Power Toys mouse utility. Like obviously this is an extension, right? Like this is something I have to download. Power Toys. Okay, so yeah, let's get it. Power Toys. Okay, so how do we? Windows 11, no, not Windows 11. I thought this would be a lot. I thought this would be really easy. I thought it would be like you Google it and then it's like bam, there it is. You know what I mean? Not a how-to, just like Microsoft app. Mouse pointer highlight. Here we go. Microsoft apps. Mouse pointer highlight. Bam. Mouse pointer highlight program, very small. There we go. There it is. I read that as catnip. 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 Icon's cat, it's obviously. It was meant to be interpreted like that. Okay, wow, look at that. That was so simple. Okay, cool. So the size, that's a little bit big. I don't necessarily want it that big. Let's just do like 10. 10. I mean that's alright. Let's do like 12, 15. Let's do 15. There we go. 15 is nice. Opacity, I mean, I don't like the color. I really don't. The color, I don't like it. Green, would I rather green? I think I like green better. Green light means go. Why is it black? I don't want black. I want this nice, like, this nice green right here. Yeah, green light green. Click highlight. So this is when you click, it changes. Oop. Yeah, I don't actually want that. I don't think I want that. I think I just would rather. And let's see opacity. Let's just see 50. Like, so it doesn't stand out too much. That's a little like, I would want it to be like 100 maybe. A little bit more, 120. Let's go up to 255. Yeah, that's way too much. It's just like 130. I feel like that's good. You can still read through it. Go a little lower. We'll go back to 120. I think I like that. Yeah, that's fine. Yeah, that's pretty good. The color, I don't know. I kind of, maybe the yellow is better. Why is it that the yellow is better? I don't know. It is. What if we did like this bright blue? I kind of like that. This ice blue. It would be either that or the yellow. The yellow does kind of like jump out at you, but the ice blue also does. And then the green. I'm kind of like being picky here. I need to just like pick one and just move on. Yeah, I think I like the green actually. I'm just gonna go with the green. So we'll go with this. Apply setting. Okay, so now I can just like exit, or does it? Oh, it goes away when I exit, so I have to have it open. Which is like, that's okay. What was it called though? Cat Mip? Like, how do I find it? Cat Crack? Downloads. Mouse pointer installer, but now it should be like installed, so it should be. It's not an extension. It's mouse pointer highlight. Do I just like, where'd it go? I mean, I installed it, yeah, but where did it go? I don't see it on my desktop. Like, what the dude? I swear, the old Windows 7, remember when you actually searched for something and like it worked? Like, you searched for a program and you could find it, just like bam. It's crazy because now you actually can't. Like, where did it go? So I guess I gotta Microsoft Store. So this is from the Microsoft Store, so this should be an app. Mouse pointer highlight. It's checking for updates. Like, open. Okay. But like, where does it exist? Strange thing. Whatever. I guess there's no way to have an icon. Like, you have to. So I go to Microsoft Store. Is this how I have to do this? And then open it from here. I guess is what I have to do. Share. What is this? Copy the link to open. Is that what? Is that something that I could like paste a shortcut and then paste it and then hit next and then called mouse highlight, and then if I click it, does it work? Really? Well, this is unfortunate that it's telling me to download it again. This has something to do with the I don't know what happened. It's something with my Windows, I think, because it does the same thing with like Paint. Like, I have to reinstall. Okay, so I can pin this to the taskbar. So let's see if this works. So if I exit out, it's pinned to the taskbar. Okay, cool. There we go. Figured it out. Boom. Boom. We did it. Yeah, I've been meaning to do that so you can like see where my cursor is, because I know sometimes if I'm talking, it's like, where's the cursor at, bro? It's like fucking like your Harry Potter. You gotta find the golden snitch. You know, looking for a cursor on the screen. So let's see if the strum works. Do it though. It do work. All right. So I'm not really into the goat right now. I really like the goat is kind of intense. I'm not feeling that intense right now. I think the penguin is better. Yeah. Penguin is a little more lighthearted. The goat is like ready to ram you. He's a little intense. Okay. Now I spent the like first part of the morning. It was 10:15 when I started, but I ended up like looking up some stuff, what I want to learn next, which like I kind of already know, but I'm still kind of like looking ahead and just kind of like re-feeling things out to see like make, you know, what direction am I going in with the like the career path and stuff, and like what am I learning, what am I doing versus what I should be learning, what, you know, like I need to learn data structures better. Like I know about data structures, but I don't really like, I can't really tell you on a deep enough level to where an employer might, you know, need me to be able to explain things and you need to understand them to be able to make the right decisions. But like, you know, you can still get it done if you just use a certain data. Like you don't have to be an expert on it to actually do the work, but to like do it amazingly, yeah, you need to have a great understanding of like all the different data structures, linked lists, arrays, stacks, queues, which like I all those except like linked lists. I'm saying like why you would use a linked list. I'm sure that there's reasons because of like how great they are, but just like I don't know, I've never used a linked list, and yeah, anyway. Matter of fact, just for fun, as a quick little learner, let me just ask Claude, because Claude is the best AI so far, I think. List slash array versus linked list, and it's just like, why would we use a linked list over a regular list? Because that's kind of what I don't understand. Like I understand the concept of a linked list, but I guess if like the data that you're dealing with, if you want to like go to the next one like one at a time, it's better maybe. I don't know. I'm not sure honestly. Here's a comparison of list arrays and linked lists. List arrays, contiguous memory allocation. Contiguous memory allocation is a memory management technique that assigns a single uninterrupted block of memory to a process or program. This allows for efficient read and write because data is stored sequentially. So contiguous means like together, like the contiguous states are the, you know, it's like the island of the United States, like, you know, all the ones that are together. It's a memory management technique that assigns a single uninterrupted block of memory to a process or program. Okay, that makes sense. Constant time random access, O of 1. And I'm pretty sure linked list is O of n for that. So like basically you can use an index and it's always O of 1. Like it never multiplies the further it is in the list, but I think a linked list is like that. A linked list is O of n, meaning if it's 10 elements in, then it's O of 10, which is like really slow, as to where a regular list you can just boom grab it. A linked list you got to start at the beginning and go and then grab it, if I understand that correctly. Constant time random access. An array is a linear data structure. In an array, the operation to fetch a value takes constant time. It means that regardless of the input size, the execution time of an algorithm remains constant. Yeah, I mean that makes enough sense for me to move on. Fixed size in static arrays. So like, yeah, I think a list is normally like, well, a 64 bytes or something, and then it like, once you pass up that, like go to the next level, it changes to like 100 something, and then once you get that one, then it like, it expands and it keeps expanding, you know. So it says faster. Let me make sure I understand this correctly. Fixed size in static arrays. Explain further. Static arrays have a predetermined fixed size that cannot be changed after creation. Memory allocation. Allocated at compile time or declaration. Total memory size is set immediately. Cannot dynamically resize. Oh, okay. Well, this is for C arrays. You say int array of 5 creates exactly 5 integer slots. So in C you declare it, but Python it's like set. Memory is pre-allocated and cannot expand, contract. Memory management, precisely defined memory footprint, no overhead for resizing. Risk of overflow if more elements added. Potential waste if allocated space underutilized. Performance advantages, faster memory access. Okay, performance, faster memory access, predictable memory layout, minimal allocation / deallocation overhead. Limitations, cannot add elements beyond initial size, requires manual reallocation for expansion. Potential memory inefficiency. Overcome these limitations. So dynamic, okay, so dynamic arrays are not used in Python. Static arrays are not used in Python. Python uses a dynamic array. Overcome these limitations by automatically managing resizing behind the scenes. Right. So, okay, like in Python, they start at 64 bytes, then go up to 124, etc. Claude's thinking really hard about this. Claude is unable to respond to my message. Let's see, bytes. Like, I probably need to be a little more articulate, I guess. Think about that. They start at 64 bytes, then go to 200. Dynamic arrays use a growth strategy that's more sophisticated. Initial allocation starts smaller than 64 bytes. Uses a slots approach. Typically starts around 4 to 8 elements initially. Increases exponentially when capacity is exceeded. Common growth factor is 1.125, which is a 12.5% increase. Allocates new, larger memory blocks. So once you pass up the 1, it increases by 12.5%, and then once you pass that up, it increases by 12. Etc. etc. Copies existing elements to new block. Allocates new, larger memory block. Copies existing elements to new block. Old block is garbage collected. Oh, so it's like 4, 8, 16, 32, 64. Performance considerations: amortized O of 1 insertion. Occasional copying overhead. Efficient memory utilization. Occasional copying overhead. Oh, I forgot I need to add this note. Okay. Amortized O of 1 insertion, occasional copying overhead, efficient memory utilization, automatic memory management by Python and turtles. So this is like, yeah, Python is a high-level language. It does a lot of that's like complicated. Wait, say complicated. Tedious. Detail. All the like extra stuff. It does all this in the background. You don't have to do it manually. And Just giving my face a quick wipe down after work. I didn't take a shower. I didn't really get like gross at work today because I scanned instead of doing what I usually do. So I kind of had it easy today, but just feeling kind of grimy here. So this is good to know. All right, back up here. So we have contiguous memory, blah 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 blah. How did we? What happened to our? Okay, I'm tripping. So we have list arrays are continuous, constant time random access, fixed size, and static arrays. And so static arrays are predetermined and they're faster, blah blah blah. Okay, I get it. Now we have the rest of these bullet points. Faster for indexing and iteration. So regular list arrays are faster for indexing and iteration. That seems to make sense. Better cache performance. What does that mean? What does that mean? Cache performance relates to how data is stored and accessed in CPU cache levels. Arrays, contiguous memory, spatial locality, predictable memory access pattern, prefetching works efficiently, entire cache line loaded at once, faster consecutive element access, linked list, scattered memory allocation, poor spatial locality, unpredictable memory jumps, hard for CPU prefetching, more cache misses, and slower traversal. Accessing array elements sequentially triggers efficient hardware level prefetching, while linked list nodes might require separate memory fetches. Explain prefetching, caching, and array versus linked list concerning this using a physical example. Physical library analogy for prefetching and caching. Okay, so array is an organized library. Books arranged sequentially on shelves. Adjacent books likely related. Librarian can quickly grab nearby books. When you request one book, librarian anticipates and pulls nearby books. Efficient retrieval of connected information. Minimal movement, quick access. Linked list is a scattered library. Books randomly placed across different rooms. No predictable location pattern. Librarian must walk to each random location. No efficient way to anticipate next book's location. Constant movement between distant sections. Slow, inefficient retrieval. And the cache parallel would be array, like a librarian knowing book sections in advance. Linked list is like librarians blindly searching each room. Anticipating and preloading likely needed information. Anticipating and preloading likely needed information. Okay. Cache line, grabbing multiple books during single trip. Key performance and back. Arrays, efficient, spatial locality, linked list, frequent cache misses, and prefetching reduces memory access latency. Frequent cache misses. What is a cache miss? Cache misses. Reduces memory access latency. So this is what I like. My new thing is the first little bit of my session. I'm gonna spend just learning a little bit about certain things. It helps with burnout. You know, it kind of pumps you up. So prefetching reduces cache misses. Failed attempt to read data from cache. Failed attempt to read data from cache. CPU must retrieve data from slower Main memory. Okay, right, yeah. I kind of forgot what a cache was for a second. I'm dumb. Increases processing time. So cache is like really close, and then like main memory is like, oh, it's got to go way in the back. Cache is like the front of your car. You got the stuff that you can grab like right here, and then like the main memory is every like in the back. You got to get out of your car. You got to go to the back. You got to open the hatch open. You might have to lift it, the flap, whatever. Compulsory miss. First access to data. Compulsory miss is a first access to data. Capacity miss is cache full. Conflict miss, multiple data map to same cache location. Prefetching latency reduction. Predicts future memory needs. Loads data into cache before CPU requests. Reduces waiting time for memory access. Hardware software anticipates data requirements. Minimizes processor idle time. Yes, you see this is like a CS computer science level that I really need to take computer science 101. I need to do that because I really kind of like skipped over the basics, and not necessarily the basics, but really understanding this stuff like on a deep level is foundational. Understand all this stuff. Necessary, actually, I would say, probably, if you want to get a job. So, example, without prefetching, wait 100 cycles for memory. With prefetching, load data during idle cycles. I don't really know what that means. Estimated 30 to 50% latency reduction. Effectiveness depends on accurate prediction, memory access patterns, and hardware algorithm sophistication. So what determines our accurate prediction? Temporal locality. Recently accessed data likely to be accessed again. Predicts based on recent memory access patterns. Okay. Spatial locality. Adjacent memory locations likely to be accessed. Okay. Okay, I'm sort of understanding this a little bit. Predicts nearby memory regions. Stride prediction. Detects regular memory access patterns. Predicts nearby memory regions. Detects regular memory access patterns. Detects regular memory access patterns. Identifies consistent memory jumps increments. Machine learning techniques. Neural network based prefetchers. Learn complex. Why does this have prediction factors? Oh, it's so we'll use machine learning. Neural network based prefetchers. Learn complex access patterns. Adaptive models. Hardware characteristics. Cache size. So this is what determines the accurate prediction is hardware characteristics, cache size, memory hierarchy, processor architecture, algorithm, and then algorithm complexity is number 6. They should indent the bullet points versus the numbers because it doesn't, like, it's hard to notice that. Algorithm complexity is number 6. Linear versus non-linear access. Predictable versus random access patterns. So machine learning, neural network based prefetchers. So ML software built into OS helps this. Neural network prefetchers. Key aspects. ML models embedded in hardware. Integrated into CPU cache controllers. Learn memory access patterns dynamically and predict future memory needs. Recurrent neural networks. Analyze historical access sequences. Build probabilistic memory access models. Adapt to changing program behaviors. So that's pretty cool. Okay, and then a neural network. Neural network is like, I sort of understand that, but I want to see what they say. Layers of interconnected neurons. Input layer, hidden layers, output layer. Processes complex patterns, learns from data, makes predictions, classifications. Key components: neurons, processing units, weights, connected strengths, activation functions, determine neuron output. Back propagation is the learning mechanism. Training data, input data, forward propagation, compare output to expected result, adjust weights, repeat to improve accuracy. Types feed forward. Okay, yeah, so this is like a different, I went deep enough there. Anyway, back to list arrays. So linked lists, or regular lists have contiguous memory allocation, constant time random access, fixed size, faster for indexing iteration, better cache performance, less memory overhead, but is inefficient for insertions or deletions in the middle. Okay, so if you want to, because you have to move each element over one space, as far as I understand that. Like, it makes, whenever you insert, you have to move, you know, like, if you put something in the middle, you have to move over everything else to put that one there. See? I'm guessing the linked list is better for that. So the linked list, non-contiguous memory allocation, dynamic size. So that could be better. Efficient insertions, deletions anywhere, O of 1. No random access. So accessing is bad. Accessing is O of n, as to where a regular list is O of 1 access. But inefficient insertions, deletions in the middle is O of n for a regular list, as to where a linked list it's of O of 1 anywhere. More memory overhead. Stores next previous pointers. Yeah, so overall it takes up more space. Worse cache performance and slower iteration. So you use array when you need fast random access, no size in advance, want memory efficiency. Use a linked list when you're frequent insertions, deletions, dynamic size needed, and you don't need random access. What do they mean? What do they mean by random access? Common notation: arrays dynamic, arrays in Python, array lists in Java, linked list doubly, singly, linked lists in many languages. Okay, so what do they mean? Don't need random access. What does that mean when you say that? When random access isn't critical. Scenarios referring linked list. Frequent insertion, deletions, dynamic data structures, memory constrained environments, sequential processing, no index base access needed. So like that I understand. I don't really, and that I understand. Dynamic data structure, I don't understand that. I don't understand memory constrained environment and sequential processing. Examples: undo, redo functionality. Undo or redo functionality. Frequent insertions, deletions, dynamic data structure, sequential processing, no index base access needed. Okay, that makes sense. Undo, redo only deals with like the next one or the previous, like boom, boom, boom. It's always like in a line, like linear. It's always like that. That makes perfect sense. Music playlist. I don't see how a music playlist would fit that description. Browser history, I also don't see how that would. Slower traversal, more memory overhead, flexible memory allocation, dynamic size management, typical use cases. Real-time systems, event-driven applications, memory-efficient algorithms, implementing other data structures. I'm not gonna lie, guys. Like, this is lots of this language is over my head. Like, I don't really understand. This is like high in that. Like, what are you talking about? You know what I mean? Like, I get the undo redo, but that's how things are when you don't understand them. They're just like, huh? What? It's like in the cloud up there, you know? You gotta go up there and get it, and then bring it back down to the ground and understand it. Explain in plain English. Explain in second grade language. Yeah, explain just like a little kid. Nope, you can't answer that. Okay, that's fine. Music, I don't understand. How would a music playlist how would that work better as a linked list? Linked list playlist implementation. Music playlist advantages: easy song insertion deletion, no fixed size constraint, efficient playlist modification, quick reordering of tracks. Title equals title, next none, previous none. Head equals none, current, add song. O of 1 insertion anywhere. O of 1 removal. Okay. O of 1. O of 1 removal. Next song, quick track navigation. Bi-directional movement. Instant song insertion removal. What allows it to be O of 1 insertion deletion? It's the node aspect of it, right? It's the node aspect of it. It's the node aspect of linked lists. Claude's having trouble understanding that. Okay, whatever. I mean, we're good. Linked list uses node for quick traversal. That's, you're not gonna be able to answer that, Claude? Long chats cause you to reach your limits faster. I mean, well, damn. Nodes, okay, there we go. Nodes and linked lists, core concepts, individual data containers, store data and reference to next previous nodes, enable quick traversal through connections. So a node, then we have def init, which takes self data. So then we have data equals data, and then we have next equals none, which is reference to the next node. And then previous, which is optional previous node reference. Follow node references, O of 1 insertion deletion, O of n for accessing specific index. I'm trying to understand, why is it O of 1 for insertion? Key advantage, direct node linking. No need to shift entire data structure. Efficient for frequent. Why is it no need to shift entire data structure? Oh, because it doesn't use it. It just, like, if you add something, it basically creates a new it just changes the reference to the next node for that particular node. Yeah, I'm really understanding this now. I think no need to shift entire data structure. This is due to previous node reference to next node being changed and not having to alter rest of list. Exactly, in a linked list insertion deletion process, change node references, no physical memory shifting, adjacent elements unaffected, O of 1 operation per target location. Inserting node between A and C. Before is A, B, and C, and then after we have A, new node, B, and then C. Simply update references. A next equals new node. A next is new node. And then new node next. A dot next equals new node. New node next is B. Okay. Okay, that's cool. Point manipulation, node data movement, memory efficient modification, contrast with razor priority element shifts. So linked lists are better for data that is usually handled sequentially or in order. Linked lists excel in scenarios with sequential processing, frequent insertion deletion, dynamic data structures, order dependent manipulations, undo redo functionality, music playlists, task queues, browser history, memory management. How does a linked list real-time system fixed size data? Okay. Memory management, how does that relate to linked lists? Memory management with linked lists. Core applications, dynamic memory allocation, free memory block tracking, efficient memory fragmentation handling, implementation methods, free list management, memory pool allocation, quick insertion removal of memory blocks, tracking available memory segments. Key advantages, O1 memory block allocation. Alright, yeah, that's over my head. That's a level of CS I don't understand. That's enough. I understand. Okay. So, and then last thing, difference between doubly, singly linked lists. That'll be our last thing I'm gonna ask it. Him, Claude, her, whatever. Singly linked list, one directional link. Each node points to next node. Less memory usage, forward traversal only. Simple implementation. Doubly linked list, two-way linking. Each node has previous next reference, bidirectional traversal. More memory overhead, more flexible manipulation, can traverse backwards. Use case, flexibility. Singly, simple sequential processing. Doubly is for complex data structures requiring backward, forward movement. Example use case of doubly. The English use case is browser history. Navigate forward, backward, quick page, revisiting. Efficient navigation tracking. Undo, redo functionality. Bidirectional operation history. Okay. Ah, okay. Instant state reversal. Efficient memory management. Okay, I kind of get this. I kind of get, like, I think I'm understanding. Yeah. I think I'm understanding, like, on a deeper level, the linked list thing, especially with doubly. Like, linked list is more about, like, you're reading it, you know? Like, a singly linked list, like, you're reading it. A doubly linked list is, like, you're traversing it. And then, like, a regular array is more for just, like, you don't know what you're gonna do with it. You might grab this, you might grab that, you might iterate, you know what I mean? You might do all kinds of stuff with it. So I think, like, yeah, regular lists are just more efficient most of the time, but linked lists are linked lists are useful for sequential. Basically, just keep it simple. Yeah, sequential. What do you call it? Sequential iteration, sequential processing, sequential processing. And just to make sure I understand what sequential processing means, it's and then W linked list has a head and a tail. Oh, so it has, yeah, so you just reference sequential processing linked list, process data elements in order. Sequential processing in linked list, process data elements in order. Traverse list from start to end, ideal for iterative tasks, minimal index overhead. Data streaming, event processing, linear algorithm implementations. Queue-like operations. Okay. Oh, then traversal time, memory efficient, low computational complexity. Example scenario: process sequentially current linked list head and then while current. Process each node. Process current data. Current equals current.next. Okay. Easy, simple. It's one of the most simple things I could have imagined in computer programming is a linked list. Yeah, now it really makes me wonder, well, how does a regular list work on, like, you know, the really, like, the CS level, you know, like the low level. But that's for another time. I don't, you know, I don't really need to do that. Spent a lot of time doing that, too much time, honestly, but what's done is done. So now we have 13 minutes left till break. Then I'm gonna go to the gym. Yeah, I spent too much time looking up that shit. Oh well. Life does indeed go on, regardless of the bad choices that I make. So it's 11:37 was our start. We really just learned about linked lists and stuff. Learned about linked lists, etc. via Claude, and then now from 12:17 onward, we are going to progression text assigned function. Okay, we continue refactoring progression text assigned function to internally call enter continue text function or multiple choice function since they always precede it. Had to take a learning excursion to better understand class scope, namespace, reference rules, etc. Finished, refactor, and tested one times. Seemed to be working 100%. Okay, so that's what we were doing. We learned about all this stuff. Why did I put this down here? I don't know. Okay, so this was that test segment. This was to denote the difference between let's see. So this works. Static method, M1 pass, M2 calls M1, and then let's do it like this to illustrate the order doesn't matter. Wait a second, how does that work? Oh, because M1 doesn't do anything. If we change this to M2, it's not going to work. Now it's going to say, yeah, M1 is not defined. So yeah, this should actually be a class method. I think the proper thing for this would be the class method, because it's relying on the class. So then we would say cls.m1. And honestly, let's do it like this. Let's put that one up there and put the pass down here. So then we say we're calling CLS M2, but M2 doesn't exist at M2 doesn't exist before this, but it denotes that it compiles first, so it runs through everything, and then it's gonna call M2, or rather we're gonna call M1, and then M1 is going to call CLS M2, which is going to call this. And yeah, so this should not throw an error, which is correct. And then if we print, we can just print true, or tur, as I like to type mistakenly. So there we go, it works. This is just an example of how to use a class method, and we'll just say at class method example, just in case we forget. Reminder of how to use at class method to reference other class scope level methods from another class method. Yeah, using the CLS param, I guess. Can also use static method with explicit ref to class object namespace, i.e. game dot m1. Alright, yeah, so we're making something. I like 5 between them for whatever reason. 5 just gives a better, it's more space. Okay, cool. So we can exit this out. Let's go ahead and test and see. Well, actually, you got 7 more minutes, just enough time to go ahead and find, what are we looking for here? This is going to be prog text assign function. So let's look for that. We'll put, oops, def. Alright. And then, okay, so we changed this to, let's read it. Tested 1x seems this works. Thought might need add static method for teachers, but I guess using this decorator is more of a comment in this scenario to denote its purpose. Oh yeah, that was something that I didn't realize, like that I don't need the at static method. Like I don't need to. And let's just go to test reminders real quick, and the one that we just messed with, let's see, let's go right here. God, this, like, the way that it scrolled was so fast. That's because there's so many lines in the file, that's why. Alright, so this one right here, let's just make sure that I'm like correct here. So let's run this and it's gonna work, it's gonna print out true. Now if we just remove class method and, well actually this would be, well we can use this example. Let's use this example. So we're gonna take away class method and we're not gonna pass anything in at all. No param. We just have 2 methods assigned to the class, but we do have to use the explicit namespace. So we say game m2 and bam, just like that. Oh, but it says game m1 takes 0 positional arguments, but 1 was given. Oh, because we're calling it from the, we would have to call it from the game object. Then it works. Okay. So if we change it to a class method, or if we change it to a static method rather, let's see, let's copy this and then let's change this to be static method. And now we should be able to call this from gm1. So static method allows you to, refer to the class object without it basically passes the class object as the self. So at static method basically passes the class object as the self. Let me ask that. Python does at static essentially pass the class object as the self to allow calling of class methods from other class methods without any params passed. Doesn't pass the class object as self. It allows calling a method without creating an instance and doesn't receive any implicit first argument, neither class nor instance. Def static method no self, CLS, print static method, class method, right, instance method receives instance as first parameter. Okay, so if you don't have, okay, right, if you don't have any, if you don't have any decorator, it's just going to assume that you should be passing the self. So it passes the self, like it passes the self. So that's the difference actually. Static method doesn't pass the self, but allows you to access the game object, as to where no decorator passes the self. Yeah, I think I understand this. Yeah, no decorator means you're passing the self for any class method. Static method bypasses that behavior, and it obviously does something in the background to allow you, but what does it do in the background that allows you access usage of class object? Static methods don't inherently access the class object. They're essentially standalone functions defined within a class namespace without automatic access to class or instance attributes. Use class method, which receives... Yeah, but I mean, it works though. Cannot directly access class variable. Out of free messages. But, okay, but why does that work? That's what I want to know. Like, why does this work if that's not true? So let's go to Gemini. Alright guys, well actually, you know what, I'm gonna call it quits for now. I'm gonna come back later. We're gonna go to the gym, take care of some stuff. So yeah, I'll be back in like an hour or so. I'm gonna eat lunch, go to the gym, probably take a shower, and then I'll be back at it, and we'll do another hour or two. Actually, we're gonna do coding. No like questions asked to Claude and Gemini and stuff. The next hour will be just coding. No like extra